Hi everyone, welcome you to another video where we'll discuss all things that pertains Kubernetes. And today I want to introduce a particular CNI plugin. So if you are not conversant with CNI is that's the container networking network interface. So that's what actually does the network, that takes care of the networking of your pods. And we have a lot of plugins which you have like Calico, Cilium, and then you have the Meta CNI's plugins like Multus. And if you are conversant about Multus, you will realize that you have a popular IPAM solution which we call Whereabouts. So Whereabouts has been, I would say, maybe the most popular IPAM plugin for Multus-based interface. For instance, when you are making use of IPVLAN or MAC-VLAN, and then you want to assign IP addresses that are unique across your worker nodes, right? So you make use of Whereabouts for that, compared to what you have called the host local. So the host local only gives IP address from the perspective of the worker node that the pod is scheduled on, and that means that there is a likelihood that there will be IP conflict. Now, Whereabout has been, like I said, is one of the most popular one, and then if not the popular, I mean, what most people know. And also for me, also until I came across some posts, but which I can't really recollect how I actually came across this project. So this is called Spiderpool. So Spiderpool does a lot of things. And so this video will just be like a quick run through of what Spiderpool can do, the interesting features, and also it can also serve as an alternative to Whereabouts IPAM. And it has it has additional features which is quite interesting for anyone to especially if you are also running maybe edge use cases or telco use cases. You will definitely find this also interesting. So let's see. So like we said, it serves as, when we say the underlay, that means there is no it's pure, the IP traffic is pure. You can actually have access to the IP traffic even at your networking level in your environment, compared to overlays whereby you have, for instance, you have VXLAN. So in the overlay section, the IP traffic is tunneled or encapsulated with another layer for the pod traffic to communication to be possible. So Spiderpool as an enhancement to like your underlay. An example of an underlay technology would be your MAC-VLAN, IPVLAN, SRIOV also. So those are underlay examples for in terms of your networking. And compared to the overlay, of course, since the overlay has additional encapsulation, then it's likely that you suffer some network performance. But when you are using underlay, then you have you have a better performance because there are no tunneling being done. So, but don't let this. I was a bit confused also when I heard that it's an underlay, but what it actually does is it enhances the underlay plugins like MAC-VLAN, IPVLAN, right? It makes it easier for you to make use of it. For instance, and then they went ahead to give you what the advantages of the underlay. Personally, I've not really worked on with RDMA, but it says it supports it, and so like I said, it's like it has multiple features. One of the features is it's a full IPAM solution, right? Just like Whereabouts, and I think to an extent, it's from what they say, it seems to performs better than Whereabouts. though I've not tested it at a stretch. I mean, I've not tested it to see how to compare their performance. So, but one thing is currently, like, in whereabouts, in some versions, you have the case of the token issues, whereby from Kubernetes 1.2, and if you don't the token creation is now everyone. So the API, the Kubernetes API server, it requires you to always to renew the token every 1 hour, right? And it's been a back and forth communication on that, whether if whereabout has indeed fixed that. And to my understanding, I'm not sure if that's currently fixed. A case is currently open on their GitHub page, but I don't think there is much traction with that. So if you are looking at an alternative IPAM solution with that does not have like the token based limitation, then you can give Spiderpool a try. And it has, for instance, it has some enhancement to some kind of controllers in your Kubernetes cluster, like stateful set. If you go to usage, is it usage? Yes, you can see under the usage here, you see IPAM for stateful set. So this, if you go through this, you see that it to an extent it keeps the IP allocation for stateful set to be consistent, even when the pods are recreated. So the IPs will remain the same, right? But then you need to set this feature also to if you need. No, sorry, I think it's on by default. So if you don't want to use the feature, you can set it to false. I don't know why you will not want to leave it on, but that's it. So it has a good feature for stateful sets in that the IPs are consistent, right? So you see as the pod is stateful, application hope that each pod continues to be assigned the same IP address after restarts. So that's one good advantage. So, and then you have a way of so let's not go to the Multus yet. So you see one other thing that I also got to know is this default network. This is not about Spiderpool, but this is about Multus generally. So you could have your pure underlay like MAC VLAN or IP VLAN, and you still have your full networking for your pod. So assuming your cluster has another CNI, primary CNI, maybe like Cilium or Calico, right? You can actually you can override that to say that your ETH0, that's the primary pod interface, should not use Cilium or Calico, right? It should use one of the Multus plugins that you've configured. So that's one thing that's been there. It's been there for some time, but I never got to look at it. But this actually made me to go through it. So that's one thing. So like I said, this is not entirely a Spiderpool stuff. This is just pure Multus. So what this is saying is that, you see, when these pods are created, you see the IPs even are, upon restarting the stateful set pods, you see the IPs remain the same. So in some cases, it gives you some kind of stability in terms of the IP allocation, which sometimes it might be something that is important to your application design. And if that's it, then it's something that I found very cool. And also it has this feature of like your Multus config, and currently, if you want to write your Multus config, the actual CNI configuration is actually a JSON file. And from my experience, I noticed that it's prone to error, right? And one thing that Spiderpool also does is, apart from making your Multus configuration to be easier, you can also, if you don't want to install Multus directly, as part of the Helm chart, it can also install Multus for you. So if that's something that is useful to you, you can actually take a look at that. So with Spiderpool installation, it will also take care of the installation of Multus for you. Now back to the Multus configuration. So here you see that instead of the normal JSON file that you see, this is actually a YAML file. So you can see that the CR, the custom resource name, is actually called Spider Multus config. What this one does is that once this is created, once you create this CR, it will now translate this into your normal Multus network attachment definition. And then when you come here, you actually see that yes, it's actually your plain Multus with your JSON file here. You can see it. So, and some other cool thing here that you can also see here, you see enable coordinator, which you can also look at it from the documentation, right? So if you want this underlay IP address, for instance, to have access to your to the cluster IP services, right? The coordinator helps you with that. So that's why you have this enable coordinator to be true. So the enable coordinator will make sure that if you are making use of this network attachment definition as the default network, for example, it can do some other things, but for example, you want to make use of this as the default network. And you know, with the default network, that means the ETH0 will be created from this NAT, right? So, but then how do you now make sure that the pod is able to communicate with the cluster services? So that means you can do some IP tables or some things yourself, but that would be an overkill, right? So with the coordinator enabled, it helps you, it takes care of those configuration, and it makes it easier for you for the pod to be able to communicate with your services within the cluster. And it's not necessary that you make use of this. This is just a flag, right? If you disable this, you still get your normal NAT, network attachment definition. This is very cool. Like I said, it's you can make use of this to create your Multus configuration, and at the same time you are making use of it for the IPAM also. So it's a one tool that does a lot of things, and I've not even gone through a lot of stuff that you can still do with it, right? So they have other forms of usages, example usages that you can have a look at and to see, like reserved IPs. You could do an increment in terms of IP. You could say that, okay, as you are creating a deployment, you want to keep the next 3 or 4 IPs available, so that when you scale your replicas, you don't need to worry if those IPs will already be picked. So you can sort of do some kind of reservation of IP ahead of time. So it's a lot of thing to get through to, and I've been contributing part of my usage experience to the community also. For instance, I realized that it was only, first of all, it was tested only using kubeadm, right? So, and I get to test it to use it on RKE2 and then on K0S. So I ran into some issues, but with the latest changes, I think that is fixed. So you should be able to use any Kubernetes distribution with the Spiderpool. Another thing that you can make use of this is like also like in Nephew also, Nephew they have an IP function. They have a function that also can generate your network attachment definition. You could, instead of that, you could make use of this to maybe to make it more readable for you to actually know what is going on. And then one other thing is, I can't remember where it is in the documentation. It can also create VLAN interfaces automatically for you if you need that. So instead of you actually creating the VLAN interfaces beforehand on the on the network, in your host, this can also make use of it. You can make use of it to do that automatically for you. So I just thought of giving an intro to the tool, and in upcoming videos I'll see where we can actually apply this based on some deployment or workloads that might be interesting. But in most cases, this tool will be more useful for telco-based workloads, because you see it's heavily into multiple network interfaces, SRIOV and stuff, which are things that are normal that are usual with telco CNFs. So yes, so if you see here, like I was saying, you can see that the name of that they have a sub tool that can do that, which is called IFACR or IFACR ACR. So you can see it can go ahead to create some additional stuff. You see, it can create VLAN interface. It could also create a bond interface. So that's it for now, and thanks for taking time out to watch it, and see you in the next video.